Welcome. Last time we talked about acids, and today we want to continue with the bases and alkali. So what you should know is that a base is a compound which consists of oxides of metals or metal hydroxide. So in other words, what they mean is, for example, sodium. Sodium is written as sodium hydroxide. You also have zinc oxide. So these are bases. Now, between these bases, there are those bases that are soluble in aqueous solution. When a base is soluble in aqueous solution, it is said to be an alkali. So usually, those bases which have metal hydroxide are soluble. For example, sodium hydroxide, calcium hydroxide, potassium hydroxide, those are alkali because they are soluble in aqueous solution. So that's what you should know about bases and alkali. A base is just a compound of metal hydroxide or metal oxide, but an alkali is a soluble base. When a base dissolves in a solution, then it's said to be an alkali. So the point is, all alkali are bases, we agree, because bases can either be soluble or insoluble. But not all bases are alkali. And the reason is not all bases can dissolve. Now, even for bases, we have one that are stronger bases, and then the one which are also weak bases. So now, those that are stronger bases are those that completely ionizes when dissolved in aqueous. But those that are weak are those that are partially ionizes. Now, what are the physical properties of bases? The physical properties of bases are: one, they have a bitter taste. Number two, they have the pH value less than 7. Number three, they are slippery when you touch them. They feel sleepy. The number four, they turn red litmus paper into blue. So these are the physical characteristics of bases. They have bitter taste, they have pH value less than 7, they are slippery, they turn red litmus paper into blue. Now, what are the chemical characteristics of bases? We already know that when a base reacts with acid, they produce a salt and water. Take, for example, a base, sodium hydroxide, react with hydrochloric acid. They produce sodium chloride and water only. So this is what happens when a base or an alkali react with acid. Then base can react with ammonium salt to form ammonium gas. Then they can also form ammonium nitrate. So let's take, for example, sodium hydroxide react with ammonium nitrate. It will give us sodium nitrate, ammonia, and water. So this is what it gives us. This one, calcium hydroxide, react with ammonium sulfate. It will give us calcium sulfate plus ammonia plus water. So remember that the common thing that will always come out when a base reacts with ammonium salt is ammonia gas and water. So this is what you should know about the reaction between ammonia and bases. Alright, so we get to oxides. There are 4 types of oxides that we have. One is called an acidic oxide. Now, what do we mean when we say acidic oxide? We mean that these are oxides of nanometals, meaning when nanometal combine with oxygen, for example, carbon dioxide, sulfur trioxide, Then we also have sulfur dioxide. These oxides are formed when oxygen combines with a non-metal. So they are called acidic oxides. Meaning that when this oxide was to react with water, it is going to form an acid. So for example, carbon dioxide, it reacts with water, it forms the carbonic acid. So that's the meaning there. Then basic oxides. These basic oxides are oxides of metals, meaning when a metal reacts with oxygen, they form an oxide of metal. For example, magnesium oxide, then calcium oxide, aluminium oxide. So when these react with water, they form gases. You get it, eh? So sodium oxide plus water, you expect hydrogen to be formed there. Then we have the other one is called amphoteric oxide. Now, amphoteric oxide, we mean these are oxides that have both characteristics of acidic and the basic oxides. So when we combine those characteristics of a basic one and a basic one and an acidic one, we form an amphoteric oxide. And good example of amphoteric oxide is water. Then coming to neutral oxide, these they have neither the characteristics of acidic nor basic. They don't have the characteristics of either of them. And a good example is carbon monoxide. So these basically are what we call oxides. Thank you for watching.